these are two plates with us, we'll keep them parallel to each other. So what is seen to you? Just a single line of this plate and single line of this plates. So we'll draw them. This is your positively charged plate and this is your negatively charged plate. And when you ground this plate, this becomes parallel plate capacitor. Here we will be finding capacitance of a parallel plate capacitor without dielectric, means there will be no dielectric kept between the plates. Without dielectric means insulating material can be kept like air, paper, mica, glass. Okay, the area of these two plates, the area of this plate is A, the area of this plate is A. So we'll write, let A area of plates. Now this is just a surface, a two-dimensional surface. So for this we'll be finding surface charge density denoted by sigma. If plus q is the charge on plate P1 and minus q is the charge on plate P2, then the surface charge density for this and for this. Okay, initially I'll just write the formula for surface charge density. Surface charge density for this plate will be plus sigma and for this plate it will be minus sigma. So the formula is charge upon area. If instead of plates we had wire with us, then in that case it would be linear charge density, denoted by lambda, that is charge upon length of the wire. Now we'll be going with this because we have surface with us. Now we have also seen in our previous topics in this chapter for this, when you have plain sheet, what will be the electric field out of the sheet, means at this point out of the sheet, away from the sheet, at this point what will be the electric field? If your plate is positively charged, the electric field will go away from it. The direction of the electric field will be outward and the formula for the electric field will be sigma upon 2 epsilon naught. So at this point the electric field, let me call this point as M and the point on this side be N. So due to this sheet, what will be the electric field on point M? Of course it will be outward, it will be sigma upon 2 epsilon naught. What will be the electric field at this point due to this negative charged plate? It will be in this direction and that will be also sigma upon 2 epsilon naught. So what will be the net electric field at this point due to these two plates? It will be sigma upon 2 epsilon naught and the direction of both the electric fields is negative, so opposite, so it will be negative sigma upon 2 epsilon naught. That makes it 0. So the electric field at this point is 0. What about at this point, that is at point N? So due to negative charged plate, the electric field will be in this direction, and due to positive charge plate, the electric field at this point will be towards this direction, and out of the charge plate the electric field is given by sigma upon 2 epsilon naught. In this case also the formula for electric field is same, but again the direction of both the electric fields is opposite. So even in this case, means even at point N the electric field is 0. From this what we can see, that in outer region, means outside the two plates at point M and N, the electric field is 0. Now what about inner region? We all know that electric field goes from positive to negative. So the direction of the electric field due to both the plates is from positive to negative, means the direction is same due to both the plates. So due to this plate it is sigma upon 2 epsilon naught, and due to this plate it is sigma upon 2 epsilon naught, and the direction of electric field inside the two plates is same See, everyone is traveling from positive to negative. So in inner region, the net electric field will be sigma upon 2 epsilon naught plus sigma upon 2 epsilon naught. So this will be sigma plus sigma, that is 2 sigma upon 2 epsilon naught. So 2 gets cancelled. So inside the two plates, the electric field is sigma upon epsilon naught. Now what is sigma? Sigma is q upon a. So I can write q upon a epsilon naught. In this chapter only we have seen that electric field is equal to minus dV upon dx. That is, electric field is equal to, wait, I will show that to you in your textbook, that is on page number 190. Here is that equation, that electric field is minus dV upon dx. So this is chota v chota x, so I will remove this d from numerator and denominator, so this can be written as minus v upon x. Okay, now this formula is for variable electric field. Here whatever electric field is developed inside the parallel plate, that is uniform. So for uniform electric field, we won't be writing minus, we will be writing just v upon x. X is the distance between the two plates, and here the distance between the two plates is small d. So instead of x, we will write v upon d. V is the potential. So here, okay, I'll come to the diagram part afterwards. So here it is V E is equal to V upon D. So what is V? E into D. Now main topic is capacitance of this parallel plate capacitor. We have the formula for capacitance, that is charge upon V, right? Okay, charge upon potential. What is potential? E into D. What is E? We have just calculated E. E is Q. See, E is Q upon A epsilon naught. E is Q upon A epsilon naught, and this D. So Q gets cancelled. This A upon epsilon naught will go in the numerator, A epsilon naught D. This is the formula for capacitance between the two parallel plates without dielectric. We can also say capacitance of a parallel plate capacitor without dielectric. Okay, now coming to the cases. Here how many plates we have used? 2 plates. 2 plates, right? So in capacitance, the formula of capacitance is A epsilon naught D, that is 2 minus 1. So 2 minus 1 is 1. This is what we have obtained for 2 plates. For 2 plates it is 2 minus 1, that is we have 1 over here which we are not writing. For n number of plates, parallel plates, for n number of parallel plates, the capacitance will be n minus 1 A epsilon naught D, right? Okay, for 3 parallel plates, what will be the capacitance? It will be 3 minus 1 A epsilon naught D, that is 2A epsilon naught D. Hope you understood this. Okay, for cylindrical capacitor, there are 2 coaxial cylinders, means the axis for both the cylinder is same, and the inner cylinder has radius A, outer cylinder has radius B. So here the formula for capacitance is given by 2 pi epsilon naught, and L is the length of the cylinder. 2 pi epsilon naught L upon log to the base E. Okay, log to the base E B upon A. This will be the formula of the capacitance. This can be asked in 1 mark question. And for spherical capacitor, we have concentric spheres, means the center of the sphere is same. Here inner sphere has radius A, outer sphere has radius B, then the formula for capacitance is given by 4 pi epsilon naught AB upon A minus B.